I've got this potato paperweight right now. We really need to replace the handle. I want to get this working again and get it comfortable. The reason I want to salvage this is because it's a good quality stainless steel. It's gone in the dishwasher maybe 1,000 times and there's not a speck of rust on it. So for that reason I want to salvage it, and I think it can last a lot longer. And what we're going to use to replace the handle is this piece of copper, nice thick copper. It's probably used as some sort of grounding electrode at some point. And it's going to be durable, it's going to look great, it'll allow for maybe a hammered finish, something like that. And it's fairly easy to work with as well.
This video has a lot of detail in it, so in the description there are timestamps. You can go to the particular step that you like to see, and that way you're not wasting your time. It's also an innovative idea in the video for work holding on the lathe, and there is a test at the very end of the video of the final product. So the cutting process warped these pieces, so the next step is to straighten them out. Just like when you prepare a plumbing fitting, you want to prepare these parts the same way. I'm using wood. I didn't worry about getting these particularly clean, I just wanted to make sure the two mating surfaces were flat. So to join these pieces together, I'm using just regular plumbing products. The solder that I've chosen is a lead-free solder. When I clamp these pieces together, I wanted to make sure that I didn't apply too much pressure. The joint has to be filled with solder, so a small void is necessary. A regular propane torch is just too small here, so I'm using a forging torch. Here you can see the solder being wicked into the joint. Okay, I'm a little ashamed to say that I don't have a proper drill press vise yet, so I'm kind of making one up here. I've got a wood support block underneath my regular vise. It's important to note that everything on this project will be either stainless steel or brass or copper. It has to be rust proof and it has to basically last forever. Since this piece is pretty precise, I went ahead and center punched the holes just to make sure that I was on target with the drill bit. And I went ahead and drilled the holes through as well. I'm countersinking these holes to make sure the rivet has some of a head left after the top of the rivet is filed flush. And here the idea is to file some chamfers on to improve the look of this piece. It also ends up being a little bit easier to handle when the edges are broken. So the original plan here was actually to hand file everything, and a coworker gave me the idea to turn this on the lathe, so I decided to run with that idea. Since I hadn't planned for that, I had to make some modifications, and chamfering the edges is one. I don't have a working 4-jaw chuck for this lathe, so I was able to 3D print this ABS part with a pretty heavy-duty infill in order to mount this to the lathe. The plastic is a little bit slippery. I did find that it was moving a little bit, so I was able to tighten down the chuck a little bit more, and that worked just fine. Though the material looked like copper, due to the oxidation layer that was on there, it does not machine like copper, so this must be some sort of brass. So I was pretty happy with this result so far. It turned fairly well on the lathe and just needs to be fine-tuned a little bit. If I had stopped at this point, I think I would be pretty happy. It's not quite what I had in mind. I really wanted a hammered finish. When I'm hammering, I didn't really notice, but the hammer blows were breaking apart the solder joint, and those joints that are exposed are now very sharp. So after all that work, there's really no way to fix this, aside from maybe resoldering the joint, and I was not interested in a low quality solution. So I have to call this brass handle a fail, unfortunately, and I'm back to the drawing board. I found some stainless steel in my shop. It was way too large in diameter, but I was able to turn it down. I'll melt down the original handle. So pretty much all the same steps are involved here. The material is a little bit harder to work with. The hand hammering looks great. On the lathe I added a little decoration for end pieces, so a separation from the hammered look. Here I'm just marking out for the two flats that I need to put on. And here I've extended the lines with a ruler just to make sure I have a guide for the next step. So I have a smaller rivet that I'm going to be using for the mounting of this piece. And one thing that's critical here is to make sure you drill from both sides. So you want the hole to meet in the center, and that's going to preserve your alignment. If you didn't do that, your hole might be slightly off by the time it came through the other side. And that's going to have a dramatic effect on the position. Two recommendations that I have when riveting are: make sure that your pieces stay tight together. I'm not doing that here, and there's a flaw with that process. And the other is to make sure that you use a rivet that's as large a diameter as you possibly can get. What will happen with a small diameter rivet is it'll bend over rather than to mushroom out. And that happened to me here, and I really did struggle with trying to get it back into shape, and I had to trim it off at one point. So after quite a bit of hand filing to file the rivets flush and a little bit of hand sanding, here's the final product. I would have preferred the brass look, but stainless steel is good. It's going to be good and long lasting as well, and good in the dishwasher. If you enjoyed the video, don't forget to subscribe, like, and comment, and ring the bell. Thanks for watching.